Welcome back, everybody. In this video, we're going to talk more about functions and graphs and focus more on that here. So there's a lot of different things that we can get from a graph, a lot of information, and that's really what we're going to talk about in this video or in the next few videos. So there's a lot of different pieces that we can grab from a graph. And the first idea is where a graph or a function is increasing and decreasing. All right, so let's look at increasing and decreasing. A function is increasing within an open interval if the y values are going up from left to right. So the big thing is you want to remember that we do read graphs from left to right. So an increasing part of a graph would be going upward in that direction. And if you're decreasing, it would obviously be going downward. And again, as you're reading the graph from left to right. A function can also have a constant part where the y values are staying the same. Now, I am saying here in an open interval, so meaning that, within a range of values, a function will be increasing or decreasing or constant. When we write increasing, decreasing, and constant areas, we typically use the x values and we typically use interval notation with parentheses. So when we're talking about increasing, decreasing, and constant, we never include the n values because at those n values, it's sort of like, well, is that increasing there or is that now changed to decreasing? What happens? So when we write our ranges, we do use interval notation, typically speaking, and parentheses in our values there. So here is from your textbook, there's a picture that was there that I thought was nice. So you can see this part of the graph is increasing. This part is decreasing overall. Even though there's little bumps, it's still constantly going downward. And then something that was constant would have a flat part to it. Let's look at an example. Okay, so we're going to state the intervals on which each function is increasing, decreasing, and constant. And what you really want to remember is not so much to look at the way the arrows are pointing, but to remember you read in a left to right direction, which is really important. So look at your first graph here. Remember, you're going left to right. So think about where this graph is going. Let's do increasing first. So we're going increasing from here to here. Right? We're going in an upward direction from left to right. So our graph is increasing from x is 0 until x is 2. So we're going to write this as 0, 2 and use parentheses for our interval notation. Again, remember you're using x values for location on the graph. So increasing from 0 to 2. Now the graph is decreasing here to here, and there's an arrow pointing down, so we are going to continue indefinitely. But notice that it's actually also decreasing here because technically you're reading in from left to right. So I know this is going to keep going that way, but this is actually a decreasing direction because from left to right, we're going down. So be really careful there because you want to say, oh, it's going up, but really from left to right, we're coming in and coming downward. So where are we decreasing? Well, on the left side here, the value actually keeps decreasing forever, all the way through negative infinity. It's going to always be kind of coming in downward here. So it starts at negative infinity, and it stops decreasing at x equals 0. And then it starts decreasing again at x equals 2, and continues forever to the right, decreasing through infinity. And then what you can do here is you can put a little U symbol in between to represent that both of these parts are decreasing sections of the graph. And for this one, it is constant nowhere. So it is not constant. Okay, so not constant anywhere. All right, now let's look at this one here. So I'm going to start with increasing. And again, we're reading left to right. So I see we're increasing from here to here. So we start increasing at x equals 0, and it's going to keep increasing forever. So we're going from 0 to infinity there. Now, if I look, the graph is never decreasing. So decreasing is not relevant for this particular graph, but it is constant. So notice this whole section here is perfectly flat. So it is constant there. Now let's see. It's constant all the way to the left. It's going to keep going constant forever. And then we have this endpoint here at, let's see, x equals 0. So it's constant from negative infinity all the way through to x equals 0. And again, for increasing, decreasing, and constant, we do use parentheses. So I know the endpoint is included there, but really singular points are static. They don't really have direction or movement. So we like to use parentheses when we're talking about increasing, decreasing, and constant. Another important thing we talk about is the relative max and relative mins. So a function has a relative maximum. It's also called a local maximum, if you've heard that term before, if it has a maximum within a small open interval. So it usually looks like a peak or a top of a hill. So a relative maximum does not have to be the overall maximum of the function. It just means in a small region, is there a maximum area? A function has a relative minimum, also called a local minimum. Again, if it has a minimum within a small area, usually we think of this as a valley. Functions can have 0, 1, or multiple max and mins. However, they are never at the endpoints of a graph. So again, they're always within a small area. I do want to make a note here. So relative maxima and minima do not have to be the highest or lowest points overall. They just must be the highest or lowest points within a small area. The highest point, if it does exist, is called an absolute maximum or a global maximum. And the lowest point overall, if it exists, is called an absolute minimum or global minimum. If the graphs go off to infinity, then we don't count those as having a max or min because they're infinite. So let's look at this one here. So let's see. Let's say there's a relative. So for this particular graph, and I just have a link here because I use this graph from Cool Math, which is a nice, also fun website if you want to check it out. They do a lot of good explanations there too. Notice that we actually have a few different local or relative maximums. So there's one here, right? It's a little peak in a small area. There's one here, a little peak in a small area, and there's one here. So we have relative maxima at, let's see, x equals, let's see, -1, 2, 3, 4, this is -5. At x equals 0 and at 1, 2, 3, 4. So we can say there are relative maxima at x equals -5, 0, and 4. We could also say the relative maxima are, so this refers to your x values, and this typically refers to your y values. So here our y value is 1. This one is at 3, and this one is also 1. So the relative maxima are 1 and 3. So you just want to be careful on the wording. Are they asking you where the maxima occur? So at where the x values are, or usually they just want the value. The relative maxima are 1 and 3, meaning like what are those peak values for the y? So you just want to be careful with the wording. We do also have 2 local or relative minima. So 1, 2, 3 at x equals -3 and at x equals 2. And the relative minima are, let's see, y equals -2 and 0. So those are your x values, and those are your y values. Okay. A lot of times they just want the y value. So if they say, you know, what's the relative minimum or what's the relative minima, then they're usually looking for the y values. You want to be careful of the wording. So just when you're going through examples. Maxima and minima are just the plurals. So maximum would be singular, minimum obviously would be singular as well. Now your book doesn't really talk about global maximums here, so I don't want to spend too much time. But just as a note here, there is a global max. So notice the highest point of the graph is also right here. So this would have to be the global max or absolute max in this case. But because we go down to negative infinity, there is actually no global minimum. Okay. So your relative max and mins are just within a small area. You can have multiple or you could have none. And then the global max and min are the overall highest and lowest values of that graph if they exist. If something goes off to infinity, in this case, it's going down to negative infinity, we say that there is no global minimum.